Hey guys, I'm coming at you today with something that looks pretty darn different from what we have been doing. Day 9, our last real official day before we get into our review next week. Day 9 is all about not proofs, but another word here, probability. Now we saw a little bit of this, we saw back in chapter 1. So if some of this looks a little familiar to you, that's probably why. Big things today, we're going to be talking about finding the probability of a simple event. So what are the chances something happens? We're also going to be talking about how we add if we're dealing with mutually exclusive events, and how we may need to add and do some subtracting with some non-mutually exclusives. And then here's going to be something brand new, independent and multiplication. So just like how addition usually goes with mutually exclusive, we're going to be seeing multiplication and independent today. So, and you're just going to be able to figure out, hey, can I tell if two events are going to be independent? And if that sounds confusing, it's because you probably haven't learned it before. And we'll be talking about that a little bit later today. But let's get a quick reminder. Mutually exclusive, whenever you hear those words, that means two things that cannot happen at the same time. Boom. Mutually exclusive means they cannot happen at the same time. An example would be flipping a coin and getting, here's the key, heads and tails. So flipping a coin and getting heads and tails, that is mutually exclusive. That cannot happen. Now check it out. We've got two things here. For mutually exclusive events, the probability of A and B happening at the same time is 0. So in other words, if we flip a coin, the chances of getting heads and tails is 0. Cannot happen. Now, if two things are mutually exclusive, like the probability that we get maybe a zoo situation, where you go to the zoo and we say, hey, what are the chances that we run into the lions or we run into, the tigers? So two events that obviously they can't happen at the same time, but we're saying, hey, we're fine with either one happening. And if that's the case, that's going to help our probabilities, right? It essentially means we want to know the probability of one thing or another thing occurring. And if that happens, we just simply add their probabilities together, assuming there is no overlap. Now, if there is overlap, we'll talk about that on the next page. But check it out. Event A and B are mutually exclusive events. Let's find out what the probability of getting A or B is. Okay. So then we've got the probability of A is 1/3. Probability of B is 2/9. So the probability of A or B happening is just going to be 1/3 plus 2/9. And if you add those two together, again, get a common denominator, you can multiply that by 3, which means you have to multiply that by 3. That's really 3/9. If you then add that with 2/9, you get a 5 out of 9 chance of A or B happening. So mutually exclusive events, one or the other happening, that's going to improve our odds because we're fine with one thing or the other thing happening. How about number 2? We go to an aquarium, and we've got 24%, 0.24, our catfish, and 13% are black tetras. So that'd be 0.13. I'll put 0.24 up here. That way we're not too confused. And then 0.8 or 8% are angelfish, 0.08. What's the probability of randomly choosing a fish that is a black tetra or an angelfish? So hey, we go to an aquarium. We're cool with getting one or the other. Well, black tetra, that's 0.13 plus angelfish, that's 0.08. So in other words, we got a 0.21 or 21% chance of running into one or the other. So our odds are improved when we're fine with getting one or the other. And so we would write this as the probability of black tetra or angel fish. Sorry, it's a little messy, guys. Yep, the probability of a black tetra or angelfish. That plus that. I'm going to let you guys try number 3. Again, I trust you guys on this. What's the probability of randomly selecting a student who lives less than 1 mile from school or more than 3 miles from school? And again, we have the setup here. You can pause the video. When you unpause, I'll have this answer here, but I feel pretty good about you guys getting this one. And so you guys can see, probability of less than 1 mile or greater than 3 miles, 53 plus 21%, 74%. Today's going to be a pretty quick day, guys. Not a ton of math here. Now, here's where things get just a little bit trickier. Check it out. So, if we have events that are not mutually exclusive, that means they maybe are happening at the same time. We just got to be careful here, because what's the probability of A or B happening if A and B could happen? They have things in them that could happen at the same time. So then we add the probabilities still, but then we have to subtract out what we call the overlap. And really the best way to explain this is to look at an example. Check it out. A spinner has 5 equal sections, numbered 1 through 5. Okay, so our sample size for this spinner, again, sample size means all the things that we could get is 1, 2, 3, 4, and 5. So 5 different things we could get here. Now, what's the probability of the spinner stopping on a number that is a multiple of 2 or is less than 3? Interesting. So multiple of 2. What numbers are multiples of 2 that could be in this spinner? Oh, that would be 2 and 4. Now here's the thing. What about that are less than 3? That would be 1 and, oh no, 2. Guys, we got some overlap here. We're counting 2 in both these events here that are not mutually exclusive. So our overlap is one thing, 2. So we have a 2 out of 5 chance of getting a multiple of 2, right? 2 numbers are multiple of 2 on this spinner, and we have a 2 out of 5 chance of getting a number less than 3, 1 and 2. But we also have a 1 in 5 chance of getting a number that overlaps in both of these. And if that's the case, we have to subtract out the overlap. So you do 2/5 plus 2/5, and then we subtract the overlap. And so what would be our probability of getting a multiple of 2 or a number less than 3? 2 plus 2 is 4 minus 1. We got a 3/5 chance of getting one or the other. So I'm going to let you guys look at number 2 and number 3. And so just take a moment. These number 2 is just straight up. I'm not going to do the Travis Scott voice, I promise. How about straight voice? This is just a straight mutually exclusive problem. Number 3, going to have some overlap. So give me your best shot on 2 and 3. And watch out for the overlap on 3. All right, check it out, guys. Number 2, straight mutually exclusive. We got 28 total books, 16 are fiction, 8 are math. So if we're fine with getting fiction or math, if we randomly select a book, that would be 16 out of 28 plus 8 out of 28. Gives you 24 out of 28, which is 6/7 if you reduce that down. Number 3 is a little bit trickier. We got some overlap here. We got a spinner with 6 sides, 1, 2, 3, 4, 5, 6. What are the chances of getting odds? Well, there are 3 odd options, 1, 3, and 5. That's 3 out of 6. Plus, how many numbers are greater than 2 on this thing? Well, you got 3, 4, 5, 6. That's 4. But wait a minute, we got some overlap here. 3 shows up twice in these 2 events, and 5 shows up twice. So we have to subtract out that overlap. There are 2 things that show up twice. So 3 plus 4 minus 2 gives you 5 out of 6. All right, guys. So now we're on to the final piece here, talking about not mutually exclusive anymore, but independent and dependent. Now, this is a little bit different. These things can happen at the same time. So let me remind you, can happen at the same time. Independent events are events that occur and do not affect how the other event happens. So, for example, if I roll a die and flip a coin, if I do that at the same time, those events have nothing to do with each other. In fact, check it out. Right? That and that had nothing to do with each other. They didn't affect each other. So those are independent events. Now, dependent events, those do affect each other. So keep that in mind, guys. With dependent, these are events that do affect each other. And so what I want us to do is I want us to just see whether we can label these as independent or dependent events. Just going to be a little labeling here. How about number 1? We get an odd number on a spinner, and we draw a red marble from a bag of marbles. Well, those don't have anything to do with each other. That's independent. You could just put an I for independent or a D for dependent. How about that? You choose a class member for your study group, then you choose an additional classmate. Ooh, wait. So the classmate we chose for our study group, that person then will not have a chance to be chosen as the additional classmate. So this is going to make that dependent on it. Whoever gets chosen second, that's dependent on who we chose first. How about we roll a 3 on a cube, or we choose a heart from a deck of cards? That's going to be independent. Number 4, 2 cards are selected without replacing the first card. Ooh, find the probability of selecting a king and then selecting a queen. Well, if you select a card that's not a queen with your first card drawn, then you have better odds of getting a queen now that there are fewer cards in the deck. That is 100% dependent. I'm going to let you guys try 5 and 6 real quick. So unless these two salmon are fighting each other, these two salmon are fighting each other to get through this dam. These two salmon aren't going to affect each other getting through. So that's independent as well. All right, and now let's talk about the math side of things. So with independence, if 2 events are happening independent of each other, we use the multiplication rule to say they're both happening simultaneously. So for example, event A has a probability of 0.6. Event B has a probability of 0.2. If A and B are independent, what's the probability that both events occur? Now guys, if these 2 events are occurring at the same time, will that help or hurt our odds? If we're trying to say what are the chances that both happen? Well, that's going to hurt our odds. Because, the chances of something happening are one thing, but to have 2 things happen, that's going to be tougher. So the probability of both A and B happening, to represent that, we take the probability of A, and we actually multiply it by the probability of B. And when you multiply decimals, that actually makes the number smaller, which is representative of how it's going to be tougher for both these things to happen at the same time. So 0.6 times 0.2, that's 0.12. How about this next one? What's the probability of rolling a 3 or a 4 on a number cube? Okay, well that would be 2 out of 6. And randomly drawing the 4 of spades from a deck of cards. Oh dang, drawing the 4 of spades, that is 1 card out of 52. Well, hot dang. So the probability of both 3 or 4 and the 4 of spades, that's going to be 2/6 times 1 out of 52. So you can already tell these are not going to be great odds. So we multiply 2 times 1 is 2 over 6 times 52. That is 312, I believe. Let me double check. Yep, 312. And then that reduces down to 1 out of 156. So in other words, not great odds. Not great odds at all. And so guys, last page here. I told you today'd be pretty quick. We've already gotten through an entire day, almost. So this is all going to be practice. We're going to have some mutually exclusive. We're going to have some independent. This is going to be your homework to practice. And I will post the answers to some of this homework a little bit later whenever we wrap up, the next day when we wrap up the chapter. There may be a Google form over this, there may not. But let's get this done Friday. Let's get this done today. Get it done. And so, guys, I'll be talking to you very soon. If you have any questions, let me know.